Hi everyone, we're going to be working on the homework exercises here for chapter 11, looking at the time value of money and a bunch of different problems that relate to that. One thing to note, I'll split this video like I usually do into two parts with the discussion questions and more of those types of problems in a separate video, and we'll look at these we used to call them practice with feedback exercises, which I kind of like that term, the one that actually has the red X's. This one doesn't have red X's, it just has correct or not correct, and it kind of gives you information. And they're all within one tab, so it's the structure just a little bit different, but follow along and I'll guide you through. Okay, so we have our problems here, and to note, we've got different time value of money tables here in these different tabs. So we can just link to these amounts for our work as we're going through, which is kind of nice. We don't, we have it on paper in class and for some of the exams, etc., but we do have it in Excel format, which helps us be more efficient here for these problems. Okay, exercise number 1 asks, how much will $4,000 grow to over 20 years if the annual rate of return is 6%? So what we're basically saying is we have one lump sum amount, it's going to grow at 6%. And so what we want to find out is the future value of that $4,000. So we can just put in 4,000, and we're going to go to our future value table with 20 years and 6% as our guides here. So 6%, and then go down to the 20-year mark. Click enter. That's all you got to do. So that will grow to $12,828.54, and that's due to the compounding growth effect, essentially, right? So if we have the 6% return coming back, that adds into the balance, and then the continual 6% on top of that balance again increases it further. Okay, exercise number 2 says, if you need $10,000 in 14 years, how much should you set aside today, assuming an 8% annual return? So in this problem, we're kind of changing things around to have it be we know the amount that we need in the future, but how much would we, here basically, if this was, we're trying to solve for this, kind of like what we had in the first problem, basically, right? What would be the amount that we need to set aside to get us to here? So the way that we can figure that out is by using not the future value table like we just did here, but the present value table. Oops, I forgot what the factors were. That is 14 years at 8%. Let me redo that link. Okay, 14 years at 8%, and we're looking for present value. 8%, go to 14 years. So we'd need to set aside $3,404.61. If we gave that money 14 years to grow at 8%, it would turn into the $10,000 at that point later on. Okay. All right, exercise number 3. If you invest $5,000 each year, so here's the key word, each year, the same amount. That means we're going to work with the annuity tables. And we're doing that for 40 years. How much will you have at the end of those 40 years, assuming a 9% return? So that's where we're going to use the future value of an annuity. And so we just take our 5,000, we go to 40 years, 9%. Here's 9% in 40 years, very low down there. Okay, so essentially the difference then is, we're continuously putting in that $5,000 compared to these last problems where we just have one lump sum and we're seeing how that impacts. We're not saying we just have the one sum, we're saying we have multiple inputs happening every year. We're putting in the same amount essentially. So that brings us up to, close to $1.7 million over that time frame, basically. Pretty cool. Okay, exercise number 4 asks, if you want to withdraw $30,000 each year for 30 years, how much would you need to have saved today to fund these withdrawals, assuming a 7% annual return? Okay, and so in this one we use the future value annuity table, but for this problem we're going to use the present value of an annuity table. So it's a little turning this on its head sort of a thing, essentially. Okay, and so we're going to take our $30,000 amount, and then we're going to go to our present value of an annuity, which is going to be 30 years and 7%. Present value of annuity, 7%, and 30 years. I think it's that one. And correct. Okay, so this tells us that we would need $372,271.24 if we were doing those withdrawals, assuming a 7% return on that amount, essentially. The present value, as opposed to the future value here. Okay, so let's look at exercise number 5. If you purchase a machine and borrow $10,000, what will your approximate monthly payment be if you pay back the loan over 5 years, assuming a 10% interest rate? And so for these problems where it asks you to come up with a monthly payment, again, it's approximate because we're going to be using the annual amounts from the table, factors, annual factors there. But the way that we figure these problems out is we take our amount that we would borrow and we essentially divide by the present value of the annuity based on these amounts here. So 5 years and 10%. So again, we're going to go into here. Let's see, 10%, 5 years. Oh, and then we got it. Sorry, that's our annual amount. And we have to do one more thing. Divide that by 12. And that gets us back to the approximate monthly payment just by dividing over 12. It won't be exactly that because your payments would reduce your amount each month, but we're using tables that don't have monthly amounts like built in that way. So it's approximate, but it would be close. And that gets us the right answer, so we're happy. Okay, exercise number 6. We've got considering the purchase of a new machine for $32,000, that will save $6,000 per year for 8 years. If the cost of capital is 12%, what is the net present value of buying the new machine? Okay, so in these problems where we're analyzing whether the purchase of the machine is economically feasible, the net present value of buying this new machine, what we want to do is to essentially discount all of these cash savings that we have per year back to see what the present value of all those savings is going to be if our cost of capital is 12%, for example. In other words, we're saying, if you get $6,000 5 years from now, that won't be worth $6,000 to us, right? It would be worth less than that because the time value of money and discounting that back would reduce that amount essentially. And so that's basically what we're doing, is just analyzing to see whether the discounted amount, net value, the present value of these discounted payments in the future, $6,000 for 8 years, how does that compare to the actual purchase that we'd make? And is it bigger or smaller, etc. So to solve this problem, we need to do a couple things. We have to take our $6,000, that's our annuity amount, and then what we want to see is what the present value of that annuity is going to be based on these time and the borrowing costs, etc. And so we'd say 8 years, 12%, present value of annuity, 8 years. Try to remember that. Okay, 8 years, 12%. Here's that. Okay, so if I hit enter right now, I'll just do that. That will give me 29,805.84%. So essentially what we're saying is if we discount those $6,000 payments for the next 8 years back, that is essentially what the cost or the present value of those future payments would be today. essentially, when we're trying to decide if we should buy this machine or not, right? And so the net present value, then we have to subtract out the cost of buying the machine. So if you see in the formula bar there, it's kind of a lot going on in the formula bar, but we subtract out the 32,000, and that tells us that, and you can kind of see it before we even did if the present value is only 29,805, that means we're gonna, the value of that is less than the amount we're gonna pay, right? We're not earning enough on this machine to purchase it, essentially. And there might be other, there's a lot of other considerations that go into buying a new piece of machinery, etc. But this is just, kind of in a box, right, for this chapter, thinking about this all from a time value of money perspective, being very particular, right, about the outcome. And if it's economically, if it's positive, and then it's a purchase, and if it's not, then we'll say don't purchase. But in reality, there'd be a lot more concerns to take into account as well, besides just whether or not the discounted cash flows makes a difference. The net present value of those exceeds the purchasing cost. But that is one factor to think about, and for sure we should be having that in our analysis tool bag. Okay, exercise number 7 says you are considering investing in a project that will require an initial capital outlay of $120,000, and it will generate annual cash flows of $18,690 for 10 years. And we want to figure out what the internal rate of return is on basically this initial investment, if you want to think of it that way, or capital outlay, essentially. And so to figure this out, we basically, I'm going to do this on a separate spreadsheet here off to the side. I'll talk you through what I'm doing, but it's sort of a 2-part process. So take your $120,000 of investment here, essentially, and then we can look and see, basically treat this 18,690, that's our annuity amount, and then we divide the 120,000 by 18,690, and that produces 6.42. And so then we go to our present value of an annuity table, and we look for 6.4. So let me look back there. So we were at the 10 years. So we go to the 10-year row. So here's the 10-year row. And then we again divided the investment amount of 120,000 by 18,690. That gave us 6.42. And then we look through our table here, and you can see that the closest one there, and this kind of, I think the way the problems were designed, it basically exactly adds up to the 9%. And so, excuse me. And so we're basically earning 9% on that investment, essentially. So if we kind of, if you think about that a different way, and said 9% annuity, right? If you knew it was 9% or were earning a 9% return, you went to the table and you were using this factor, right? You said 18,690 times the 6.42. That would exactly get you to 120,000, essentially. So just sort of algebra, basically, right? Okay, but backing into the return, essentially, or the rate, if you will, the annual return percentage. That's essentially what we're doing there. Okay, so now we're on to exercise 8. If you borrow $200,000 to purchase a home, what do you expect your monthly payment to be? Assume a 30-year mortgage and a 7% interest rate. So this one's real similar to how we were doing where was that one? The monthly, here we go, monthly payment for the machine. And remember what we did was we took our amount that we borrow and divide it by the present value of that annuity, and then divide again by 12. So we can do something basically the same here. It's more or less the same process that we are doing here. So let's just kind of fill out this whole formula. So $200,000, and we would divide by the present value of this annuity amount that we're going to figure out essentially. Or we use the table factor, then I should say. We're figuring out the annuity. And it was 30 years at 7%. Okay, and then we want to additionally, that will give us the annual annuity, and then we want to divide by 12 to get the monthly, and that gives us $1,343.11 as an approximate payment over that 30-year period. Okay, on to exercise number 9. So if you invest $9,000 each year for 35 years, how much will you have at the end of 35 years? This is a pretty basic future value of an annuity, right? We're doing 9,000 every year, so that's our annuity. And we just have to multiply it by the table factor. And it's 35 years at 10%. So 10% at 35 years, boom. We would have $2.4 million, real kind of like a investment, personal finance, a retirement contribution type of scenario there. Okay, so let's go on to exercise 10. And exercise 10 says 30 years ago, Z company set aside $15,000 in an account that earned 8% annual interest. What is that amount worth today? So this one's kind of a relatively simple future value. It's just a one lump sum. This was us, they had an annuity where we're putting in money every time. This is just a one lump sum. And 30 years, 8% future value. 30 years, 8%. So 150,939.85. And so again, the difference, both of these basically asked us, what is this amount in the future? So that's why we're using the future tables. And then this one asked about continuous $9,000 investments, whereas this was just a one lump sum. So that's why we use the annuity table versus just the future value of a dollar table. Okay, making progress here. Exercise 11 says you're considering investing $35,000 in a project that will generate cash flows of $6,000 per year for 12 years. If your cost of capital is 10%, what is the net present value of the investment? And so in order to figure out the net present value of our investment here, we're going to do, again, real similar to what we did above. Where was that one? This one here. So we take our savings that we have every year. We look at that, discount it basically, right, to get the net present value of all those discounted future cash flows. And then we subtract that from the cash outlay to see whether or not it's positive. And if it's negative, that means that we're not going to, the present value of all those future payments will be less than what we're going to pay today. And so from a strictly financial time value of money perspective, it's not worth it, et cetera. So let's take that same tack basically and look at exercise 11 now with some different variables. Spreadsheet was going weird. And so in this problem, then we are going to, we're going to look at our future cash flows, and then we want to multiply that by the present value table, 10%, 12 years. So present value of an annuity table, 10%, 12 years, is that K14? Okay, and I'm going to click enter. It's going to be an error message because it's not complete, but I wanted to just show you this. So what we're saying is all of those future cash flows, which 6 times 12 would be 72,000, right? If you did the actual cash over that 12-year period would eventually just 6,000 times 12 is 72,000. But the fact that a dollar today is worth more than a dollar in the future, that's what we're basically doing, is discounting those future cash flows to say basically that today what all those future cash flows are worth is 40,882.15. So the next little wrinkle is just to back out, the cost of the investment to see whether it's worth it or not. And in this instance, we get a positive return. And so the net present value is positive for the investment. And we, again, strictly based on whether this is positive or negative, we say, yeah, we should make that investment because the discounted cash flows, the cash it's going to generate over the next 12 years, the value of that that amount today is greater than what we're going to invest in. So we're going to see a return over the 12 years of that, amount essentially. Okay, on to the last problem. Exercise 12, you're considering investing $200,000 in a project that will generate annual cash flows of $19,267.80 for 15 years. What is the internal rate of return for this project? So again, you got to have some little scratch paper off to the side for these kind of problems for figuring out the internal rate of return. So we take our 200,000, then we divide that amount by the 19. My spreadsheet just went weird. Sorry, bear with me for one moment. Okay, 200,000 divided by Jeez, I don't know what's going on with my Excel, but there we go. Sorry. Okay, 200,000 divided by 19,267.8, and that gives us 10.38. And then we are going to want to look in our 15-year row for present value of an annuity for 10.38. And there you go. Lo and behold, you can see that that is going to be a 5% return, basically. So again, 200,000, the investment divided by the annuity amount, essentially, the recurring cash flows, and then getting that, again, that created the table factor, basically, of 10.38. And then we have to go to it's 15 years, time frame we're looking at. So then we go to the present value of the annuity, 15 years, and then you just have to browse across this until you get right to the point of the 10.38, and good to go. And that's what your return will be. In the real world, it's not going to be as clean as it matching exactly. These homework problems are kind of designed to arrive at a specific return, but depending on it'll be maybe somewhere between 4 or 5, 6, in that percentage range is more so what you kind of expect in the real world. So cool. Okay, well that's, like I said, all the problems are just on this front page, so they're not in different tabs here, and you just scroll down and you just watch me do it, so I'm sure it makes sense. But there's no additional problems of this type throughout the rest of the tabs. It's just our discussion questions and other types of those problems. So I'll solve those in the following video, and I'm going to let this one just be a standalone as I usually do. And so I'll see you all in that next video. Thanks, everyone.